Good morning, everyone. So, yesterday and Monday, we went over translations. Today, we're continuing our work with transformations by reviewing reflections. So, of course, our topic of today is reflections. Our learning target today, I can reflect geometric figures by flipping the figure over a line of reflection. Let's remind ourselves what reflections are. So, reflections flips a figure over an imaginary line that can be horizontal, vertical, or slanted. This line is called the line of reflection. So if we look down here, we can see three different types of reflections. So in this first one here, the line of reflection is a horizontal line. The second one here, the line of reflection is a vertical line. And this last one here, the line of reflection is a slanted line. The horizontal line can also be like the x-axis. The vertical line could be the y-axis. Slanted line could be y equals x or y equals negative x. And in each picture, the pre-image, which I assume is the red image, was flipped over the line of reflection and became the image, the blue image. So reflections. So when I first taught you guys this, I taught you guys by counting the units, how far it is from the line of reflection, and then flipping it over by counting over the line of reflection and moving the same distance again. However, this may seem new to some of you, to others it's not, and it's just a little refresher. So when you're reflecting over the x-axis, we change the sign of our y value. Say we have the point, I'm going to call it A. Oh, I don't like this green. Say we have the point A at the coordinate 1, negative 4. And I want to reflect A over the x-axis. This bullet point says when reflecting over the x-axis, we change the sign of our y value. So I'm going to look at my y value, which is this negative 4 right here. So that means when I reflect it over the x-axis, A prime, my image will become 1, because I'm not changing anything on my x value, positive 4, because originally I had a negative 4, and since I'm reflecting over the x-axis, I want to change the sign of my y value. So I changed the negative 4 to a positive 4. Say we have the point B, which is at the coordinate negative 2. No, I'm not going to use a negative again. I'm sorry. 2, 5. And I want to reflect it over the y-axis. This bullet point says when reflecting over the y-axis, we change the sign of our x-axis, Miss Price. We change the sign of our x value. Oh my gosh, classic Price. So since we're reflecting over the y-axis, I leave my y value alone. However, I want to change the sign of my x value, so I'm going to look at this 2. This positive 2 should become a negative 2 because I'm reflecting over the y-axis. I am changing the sign of my x value, and my y will remain the same. Let's try some examples. Problem number 1. Reflect triangle ABC who has vertices at the point A, negative 2, 1, B, 3, 4, and C, negative 1, 6 over the x-axis. So first things first, I want to identify my points on my vertices on my pre-image. So A is at the point negative 2, 1. B is at 3, 4, and C is at negative 1, 6. Since I am reflecting over the x-axis, if I go back to my previous slide, I see that when reflecting over the x-axis, we change the sign of my y value. So for each vertice, I'm going to be focusing on my y value, and I want to change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. So A prime, remember when we're changing our coordinates to when we're changing our vertices to images, we always have to put the prime next to it so we know it's the difference between A and A prime. It's not the same triangle anymore. So A prime becomes -2 because I'm reflecting over the x-axis. My x value stays the same, and this +1 will become a -1. B prime, since I'm reflecting over the x-axis, my x value stays the same, and my y value, which is a +4, will become a -4 because I'm changing the sign of my y value. And last but not least, C prime will be -1. The x value remains the same again because we're only reflecting over the x-axis, and this +6 will become a -6. Last but not least, the last step we have to do is to identify our our points on our image. I'm sorry, I had a little. And I already have it here. A prime is the point -2, -1. B prime is 3, -4. And C prime is -1, -6. Now, problem number 2. This is not your problem of the day. This problem is only for people who this concept is kind of new to. Everybody else, if you've seen this and you already know how to do this, you could skip this part of the video and go on to problem number 3 and complete your assignment for the day. So problem number 2 reads, reflect quadrilateral MNOP who has vertices at M2, 1, N2, 4, O3, 1, and P3, 4 over the y-axis. So first things first, again, I want to identify my points on my pre-image. So M is at 2, 1. N is at 2, 4. O is at 3, 1. And P is at 3, 4. So next thing we do is to identify my line of reflection. If you read the problem, it says that we're reflecting over the y-axis. So my line of reflection is the y-axis. And 2 slides back, I said that when you're reflecting over the y-axis, you change the sign of your x value. So, starting with M prime, I'm going to be focusing on all of my x values. So this +2 right here will become a -2 because I'm reflecting over the y-axis and my y value remains the same. N prime, again, I'm focusing on my x value. So this +2 right here will become a -2 and my y value remains the same because I'm reflecting over the y-axis. And this +3 right here on O prime will become a -3 because I'm changing the sign of my x value when I reflect over the y-axis. And this one, I do not touch it at all. It stays the same. And P prime, this +3, again, it becomes a -3 because I am reflecting over the x-axis. I am changing the sign of my x value. And my y, which is +4, stays the same. Last but not least, identify your points on your new image. I already did it. It's written here. M prime is -2, 1. N prime is -2, 4. O prime is -3, 1. And P prime is -3, 4. Here's your problem 3 of today. Screenshot it if you're on your phone. Jot it down if you're on a laptop. Complete it. Answer it in your assignment for today. Have a good day, guys.